Hey, welcome to Math Extra, the show that's guaranteed to put you on the right path in math. My name is Rob Leichner, and I've always been a math person. Probably because everything we do in life is math. So actually, you've always been a math person too. We're all math people, and don't let anybody tell you different. Later in the show, I'll be joined by math teacher Mr. O'Neill from Piedmont Middle. Mr. O'Neill, are you getting ready over there?
Wow, Rob, our first episode of Math Extra. Man, I'm always ready to inspire students that they can do math. You are a math person.
Awesome. I'll see you later on, Mr. O'Neill. So what is Math Extra? On each episode, our goal is to teach you math, to help you with your math homework, and to challenge you to build your math skills both for class and for real life. We'll cover the same topic that you're covering in school. So while your teacher gets you started on a lesson, you can get extra practice by watching the show. That's why we call it Math Extra. Each lesson will be grade specific. We'll do a 6th grade lesson, a 7th grade lesson, and an 8th grade lesson. So all my 6th graders, let's get ready as we get ready for Math Extra. Hey 6th graders, are you ready to do some percents? Now I know you've seen percents before. If you like sports, you've seen them on TV. If you like to shop, you've seen them in the stores or in the sales. Now we're going to talk about what they actually mean. So what is a percent? Percents represent parts out of 100. So you can see down here, I have a box with 100 numbers in it, 1 to 100. Now, if we want to shade in 10%, that means 10 parts out of 100. So I'm going to shade in the numbers 1 through 10. So that represents 10 parts out of 100. Now I want you to think, is that a lot of the box or a little? Very good, it's a little, it's only that top row. So 10% is actually a very small part of a whole. Now let's look at the next one. So we have 86%. So that means we're going to shade in 86 boxes out of 100. So let's shade them in. 20. We're getting there. 70, 80, 86. Now, hopefully you realize through all that, 86% is most of the box. So that's actually a very big percentage. It's a very big portion of a whole. Now we're going to look at one more percent, 50%. So we're going to shade in 50 boxes. 10, 20, 30, 40, and 50. Now looking at that, how much of our 100 charges look like we filled in there? If you said half of it, you're correct. 50% is the same as 1/2. Now you might have heard the term 50-50. That's because it's half and half. There's a half chance, or there's a equal chance something's going to happen that it's not because of 50%. So 50% is one of our most famous percents. You'll hear that one a lot. Now we're going to look at something else now with 50%. Now you might think that if we're thinking about 50%, it's always the same. But really, it can change based on how big the whole is. If we look here, we have 50% of a small rectangle. Now remember, 50% is half. So I'm going to shade in half of that rectangle. Now, on the bigger rectangle, I'm also going to shade in 50%. And that's half of that one. So if we look at 50% and 50%, it's the same percentage. You might think they're the same amount. But looking at our rectangles, they're really not. Because up here, that's a lot smaller than here. So even if the percent is the same, the actual amount can be different based on the size of the hole. Now we're going to look at some basketball stats and think about how that works even more. So I miss sports a whole lot. With this virus going on, we haven't had sports in a long time. I'm a huge Hornets fan, and I'm really bummed that we've had to miss a lot of their games recently. But we can take a look at some of their stats and kind of see how the season went. So if we think about two of their best players, Devontae Graham and Terry Rozier, these aren't exact stats, but they're stats that'll help us think about percents. So if Devontae Graham took 800 shots this season and made 40% of them, Terry Rozier took 500 shots and made 55% of them. I want you to think about for a minute, who do you think made more shots? Got your guess in your head? Okay, here we go, let's figure it out. So first, Devontae Graham took 800 shots, made 40%. So if we're thinking of that 40%, 40 parts out of 100, it means that we'll be filling in 40 boxes. But each box is going to be worth a certain number of shots, because dividing 800 shots into 100 parts means that there will be 8 shots for each of those parts. So really, when we're thinking about 40%, I'm not going to fill in all 40 of them. When we're thinking about 40%, we're thinking about 40 groups of 8 shots. So the actual amount of shots he made is going to be 40 times 8, or 320. So what's really important there are both the percentage, the number of shots he made out of 100, and the total number of shots he took, so we know what each of those parts of 100 is equal to. Now looking at Terry Rozier, he took 500 shots. So take a second and think. If he took 500 shots, how many shots are in one part out of 100? Remember, it was 8 shots for Devontae Graham. How many shots is it going to be for Terry Rozier? Did you say 4? Because then you'd be wrong. But wrong answers make us smarter, so that's okay. Did you say 5? Because then you nailed it. If we put 5 into each of those boxes, then we'd end up with 500 shots for Terry Rozier. And he made 55%. Let's do a different color this time. So we're going to fill in 10, 20, 30, 40, 50, 55 boxes. So 55 times 5, 50 times 5 is 250, 5 times 5 is 275, is 25, so 250 plus 25 is 275 shots. So if we're looking at this, I know a lot of you might have thought at the beginning that Terry Rozier made more shots because he had a higher percentage. He made 55%, Devontae Graham only made 40%. But it's not all about the percentage, it's about the total number of shots they took. Devontae Graham took 800 shots. So when we're thinking about 40%, that's 40 times 8, because each of those parts of 100 are worth 8 for Devontae Graham. For Terry Rozier, each of those parts is only worth 5. So even though Terry Rozier made a much higher percentage, Devontae Graham still made more shots. Thank you, 6th graders. I hope you learned something about percents there that you can use in class for your teacher or in the real world when you're shopping, when you're watching basketball. And remember, go Hornets. On Math Extra, we take that extra step to help you with math by letting you, the students, call the show to ask us a question. So let's see who's on the line today. Caller, are you there?
Yes, I'm here.
Awesome. And who do we have calling today?
Marquise.
And what school are you from, Marquise?
Piedmont.
Awesome. And you have a question for us today?
Yes, I do. How do you convert a percent into a fraction?
That's a great question, Marquise. That's a question that a lot of 6th grade students have. Marquise, can you start off by giving us a number, please? Something between 1 and 100?
55.
55, great choice. So let's say we start with 55%. And remember from that lesson that we just did, 55% really means 55 parts out of 100. So if we want to make a fraction out of 100, Marquise, where do you think we're going to put that 100, on the top or the bottom?
The bottom.
Outstanding. So out of 100 means 100 is going to go in the denominator. The numerator is our percent, because we want 55 parts out of 100. Does that make sense, Marquise?
Yes, it does.
Awesome. Do you want to try one?
Sure.
Great. Let's say we had 38%. How would we write 38% as a fraction?
You would put 38 on the top and 100 on the bottom.
38 on the top, 100 on the bottom. Great job. Now, can we take it one more step even and try to make it into a decimal?
Yeah?
Awesome. So do you remember when you first learned decimals a long time ago? You learned about the place value and you had the decimal point. Do you remember what that first number after the decimal point was in place value?
10.
It was the 10ths place. Very good. What about the second number after the decimal?
Hundredths.
Hundredths. Outstanding. Now, if we think about that fraction we just wrote, it was 55 hundredths. 55 out of 100. Now looking at our decimal 55 is also 55 hundredths, or 5 tenths and 5 more hundredths, so that's the same as saying 55 hundredths. So you might have learned in class, you move the decimal over 2 places to make a percent into a decimal. Did you ever hear that, Marquise?
Yeah, I heard it.
Yeah, but this is why that works, because we're actually going to the hundredths place. So 55 hundredths is 55%, or 55 over 100 as a fraction. Make sense?
Yes, it does.
Awesome. Thank you so much for calling in.
You're welcome.
So before we end our 6th grade lesson, I want to give you a shot at some Math Extra credit. Find the solution to this problem and send me your answer, and we'll announce it on the next show. So let's say you're shopping for a TV, and you find a TV that costs $200, but it's on sale for 25% off. How much is that TV going to cost? Okay, 6th graders, that's it for today. What do you think? Was it too hard? Or was it too easy? I know you can all do it, because we're all math people. Stay tuned, our 7th grade lesson's coming up next. Welcome back to Math Extra, here to put you on the right path in math. And now it's time to step it up a notch. Are you ready, 7th graders? Because we're ready for Math Extra. 7th grade, are you ready to talk about circles? Yeah, it makes me hungry too. I want some pizza. But actually today we're going to be talking about the different measurements of circles. How big circles are, how small circles are, how far they are around, and all sorts of things. So let's get started. And actually we're going to start not with a circle, but with a square. You'll see why. So here you can see two things. You see the circle, the red circle, inside the blue square. And we're actually going to start with the square. Now remember, to find the area of a square, it's side times side or length times width. So it'll be 10 times 10, which is 100 units squared. Now to find the perimeter of that square, we add all the side lengths. And for a square, they're all the same size. So it's going to be 10 plus 10 plus 10 plus 10, or 40 units. So now we're going to use that to compare to the circle. I want you to think, is the circle going to have a bigger or a smaller area than that square? We're going to find out. First, we need to know about the diameter and the radius of a circle. So the diameter is the distance across the circle from one side to the other, and it has to go through the center. Now, conveniently enough, we already know what the diameter of this circle is because we know how long the side of the square is. It's 10 units. Now, the radius is a segment that goes from the center to any point on the circle. Hopefully it'll be a straight line, not like that one. Something like that. Now, the radius is half the diameter, because if you look at the diameter, it goes all the way across. The radius goes halfway across. So in this case, the radius is going to be 5 units. So here what we have a black line and a red line. And the black line is 10 units long, and that represents the diameter. The red line represents that whole distance around the circle. When you get into class, I'm sure your teacher will do an experiment with you and show you exactly how the circle can unroll into a red line like that. But for now, you're just going to have to trust me. But if you look at that red line, it's about just over 3 times as long as the black line. And actually, that red line is going to have a length of just about 31.4 units. There's actually a very, very important ratio in math that relates the circumference of a circle to the diameter. And that ratio is called pi. Can everyone say it with me on TV? Pi. Not cherry pie, not apple pie. The Greek letter pi, and it looks like that. Now it's about 3.14, but 3.14 is not pi. Pi is the ratio that describes how many times longer the outside of a circle is compared to the diameter. So, the way to find the perimeter, or we say the circumference of a circle, is multiply the diameter times pi. And I know for now you're kind of taking my word for it that the circumference is about 3.14 or pi times as long as the diameter. But please do, because we're about to use it to see something really cool about area. Now there you can see a circle. This one definitely looks like a pizza. It's broken into 8 pizza slices. And then I rearranged them. So if you think about it, what shape does it look like I rearranged them to there on the right? Yeah, some of you might think it looks like a parallelogram. And the way to find the area of a parallelogram is base times height. Base times height. Now you ready to see something really cool? If we took one of these pizza slices, or we took all 8 of these pizza slices, we lined them up side by side, the height is going to be the same as the radius of the circle. So we've got area equals base times height. Sorry, my handwriting's messy. That's why I'm a math teacher. So area equals something times the radius. Now, we want to know how long that base is. The base is 1, 2, 3, 4 of those outside sections of the circle. So if we look at the circle, 1, 2, 3, 4. So how much of the outside of the circle does that take up? Half of it. Or we could even say half the circumference. So we just found out the circumference is pi times diameter. And half of that is the base. So what is 1/2 of pi times the diameter? Well, let's see. If that's a diameter, half of the diameter is the radius. So we could say that's pi times r. So our area of a circle is pi times the radius times the radius. And hopefully you remember from 6th grade, if we have something times itself, that's like an exponent. So we can say the area of a circle is pi r squared. You might have heard that before. I'm sure your teacher said that, but this is why it works. If we take that circle with any number of slices, we reorganize it into a parallelogram, base times height is pi r times r. And the circumference, remember, was pi times the diameter. So let's try a couple of problems real fast, the type that you might see in class. I know they're going to be word problems. I know word problems are scary, but you can do it. So if the diameter of a pizza is 12 inches, how long is the crust? So thinking about a pizza, is the crust the outside, the circumference, or is it the inside, the area? The crust of a pizza is the outside, the circumference. So looking back at our formula, pi times d, pi times 12, because it says the diameter is 12 inches, equals, let me pull out my trusty calculator over here, 12 times pi is about 37.68 inches. And I love my trusty Math Xtra calculator. Now, if the radius of a pancake is 2 inches, how much space does it take up in the frying pan? So once again, we're looking at how much space does it take up? So for this problem, are we thinking about circumference, the outside, or the area inside? Very good. How much space is talking about the area? So we're looking at pi r squared. So the radius, it tells us, is 2 inches. Pi times 2 squared. 2 to the second power is 4 pi. And once again, on my trusty Math Xtra calculator, 4 times pi is about 12.56. Square inches. So I hope that helped you see not only how to find the area and circumference of circles, but also where they came from. Because it's very important to know not only the process, but also the concept behind the process. Why the area equals pi r squared. We absolutely love it when we get a chance to hear from our students, especially because I feel like it's been so long since we've seen students. So each show, we're going to answer a Math Extra video question that one of you sent us.
Hi, my name's Abby. I'm in Miss Johnson's 7th grade math class at Crestdale Middle School. My question is, what happens to the area of a circle when you double or triple the radius?
Abby, that's an awesome question. What happens to the area of a circle if we double or triple the radius? That's a great question because it also gets into scale factor, which is something else you learned earlier in 7th grade. So let's think about this. We're going to think about it two ways. We're going to think about it first from looking at a circle and then from the equation, from the formula. So looking at the circle first. If we have one circle here, and now I'm going to try to draw this well. We'll see what happens. That looks pretty good, kinda, maybe. But you can tell here, this radius is just about twice as long as this one. Now looking at those circles, you can pretty much tell that this bottom circle is more than twice as big as the top circle. It almost looks like you could fit that top circle into the bottom circle, maybe even about 4 times. What do you think? 3 times, 4 times, 5 times? We know it's going to be more than 2 times, and that's the key. We're going to prove how many times bigger later. Let's see what happens if we triple the radius. So I'm going to make this one a little smaller to make sure we have room. But there's one radius. Let's see if I can do this a little more exact. So we've got 1, 2, 3. That's just the radius. Now that whole circle is going to look something like that. Now, how many of those little circles can fit into the big one this time? Let's look. Now, it's definitely going to be more than 1. It looks like it's even going to be more than 3. I want you to take a guess. Keep that in your head for a minute, and then we're going to go do the algebra. Okay, so now let's think about the algebra behind this. So we know if we double the radius, it's going to be more than twice as big. And if we triple the radius, it's going to be more, the circle is going to be more than 3 times as big. But how much more? Let's figure it out. Now think back to our lesson. How do we find the area of a circle? Think, think, think. Pi r squared, good job. So if we do pi r squared, and let's think of a number for r. I'm gonna go with 3. No, I'm gonna go with 4. There's our first circle. So if we have 4 as the radius of our first circle, that means the radius of our second circle is going to be 8. pi times 8 squared. So here we have 4 squared is 16 pi, 4 times 4. 8 squared, 64 pi. Oh my gosh. 16 times 2 doesn't equal 64. 16 times 4 equals 64. So if we double the radius, the area increases by 4 times. Crazy. Now, let's take a look at 3. So if we triple the radius, so pi r squared, pi r squared. Let's go with the same numbers. Let's go with 4 again. So we've got pi times 4 squared is still 16 pi. We've got pi times 12 squared. 12 squared, 12 times 12, anybody? It's 144 pi. Wow, so that's definitely more than 3 times bigger. How many times is it? 16 times 9 equals 144. So if we triple the radius, the area actually increases by a factor of 9. Let's take a look at a pattern real fast, Abby. So we've got, when it doubles, the radius is 2 times, and the area is 4 times. When it triples, the radius is 3 times, the area is 9. All right, 7th graders, who's ready for the Math Extra credit? Find the solution to this problem and send me your answer, and we'll announce it on the next show. Now, going back to that table we were just looking at, we had a pattern: if we double the radius, it quadruples the area, multiplies times 4. If we triple the radius, it multiplies the area times 9. What's going to happen to the area if you quadruple the radius? And that's it for our 7th grade math lesson. Mr. O'Neill's coming up next. Are you ready, Mr. O'Neill?
Rob, now what kind of question is that? Am I ready? Man, I'm ready to get these 8th graders started on this lesson.
Awesome, Mr. O'Neill. I can't wait to see it. I hope you guys all learned something today that can help you in class, in life, and to have some fun with math, because we are all math people.
Hey everybody, my name is Mr. O'Neill from Piedmont. You know, IB Middle School here in Charlotte, North Carolina. And so we're gonna be talking about exponents today, and more importantly, any base raised to the power of 0. So let's get ready, 8th graders. It's time to do the math on Math Extra. So here's the lesson. What is any base raised to the power of 0? So when we look at our lesson here, we see all these different numbers raised to a power of 0, and I want us to answer that question today. What is any base raised to the power of 0? So let's review what an exponent and a base, or an exponent or a power, is. Okay, so let's look at the lesson. So you learned in 7th grade, let's recall what we know. We know that the 2 is the base and the 3 is the power, or the exponent. So when I look at this, I think about the power, I think about who's in charge. The power is in charge of the base. The power, or the exponent, tells the base to multiply by itself that many times. So when we look at this problem, we see 2 to the third power, which means take the base of 2 and multiply it by itself 3 times. That is what we're doing. So we're looking here and we're saying 2 times 2 is 4, and then 4 times 2 is 8. So we understand that 2 times 2 times 2 is 8. So we're saying 2 to the third power says take 2 and multiply it by itself 3 times. Now this is the mistake that a lot of students make. So many students believe that this may be 2 times 3. Okay? And we know that 2 times 3 gives us 6. Now, many times we don't remember what multiplication is all about. Multiplication is just repeated addition. So 2 times 3 really means this, everybody, that we're taking 2 and we're adding it 3 times. So when I think about exponents and multiplication, I call them like distant cousins because you're doing something repetitively. That's what they have in common, but they're not the same thing because an exponent says multiply the base by itself 3 times, but 2 times 3 says take 2 and add it to itself 3 times. So they're alike, but they're different. So let's look at this again. So again, 2 to the third power says 2 times 2 times 2, which gives us 8. And 2 times 3 says add 2 3 times, and that gives us 6. Today, we're going to have a base raised to the power of 0. Take a moment to think about that. What do you think 2 to the 0 power is? What do you believe that it is? Okay, so we're going to know what it is mathematically, all right? So the directions say, because it's important to read directions, look at the pattern going down the power. What happens when you raise any base to the power of 0? Why does this make sense mathematically? So again, I want you to keep in mind what you were thinking. I asked you what was 2 to the 0 power. Now we're going to prove if what you're thinking is correct based on the math behind this problem. So let's look at this example. So the direction says look at the pattern going down the power. So when we look at the pattern going down the power, I'm saying 2 to the third power, 2 to the second power, 2 to the first power. So 3, 2, 1, and 0 going down. That's why the arrow is there. See if we can find a pattern. So when I look for patterns, most teachers teach this teaching the mountain. So you'll see a little up mountain because I'm looking at a place visually. How are the numbers changing from one number to the next? So how is 8 becoming 4? How is 4 becoming 2? And how is 2 becoming our mystery number? So let's find a pattern going down the power. So 8 becomes 4. I think about 2 ways this can happen. I could subtract 4, but if it's a pattern, it should happen again. So 8 minus 4 is 4, but 4 minus 4 gives me 0, so that doesn't work. So that pattern is not going to work for this. And another way that 8 can become 4, if I say 8 divided by 2. Now, does that work? 8 divided by 2 is 4. 4 divided by 2 is 2. And then 2 divided by 2 is what? What is 2 divided by 2? 1. So that is the answer mathematically. If we look at the pattern, again, 2 divided by 2 is 1. Now I know what some of you all thought. You said 2 to the 0 power is 0. And that's not right according to what we see mathematically, because we're not saying 2 times 0. Remember on our previous example, we said 2 to the third power is not 2 times 3, it's 2 3 times, but you're multiplying it by itself. So 2 to the 0 power is 1 according to the math. Let's make sure this works again in the next column. So let's look here. 3 cubed is 27 because 3 times 3 times 3 is 27. Okay, and so 3 to the second power is 9. 3 to the first power is 3. What is 3 to the 0 power? So again, we're going to look at the pattern going down the power. Now, I just saw that when I subtracted, it gave me a different number. And so I'm going to go by the pattern that I just saw. Let's see if we divide by 3 going down, if the pattern works. Okay? So we say 27 divided by 3, that gives us 9. 9 divided by 3 gives us 3. So 3 divided by 3 gives us 1. Here we go again, guys. Here we go. So when you move down the power, I'm going to divide by 3, and 3 divided by 3 gives me 1. It's not 0. Again, it's not 0. It's 1. Let's try one more example to solidify our thinking. Okay? So 4 to the third power is 4 times 4 times 4, not 4 times 3. And 4 to the third power is 64. 4 squared is 16. And 4 to the first power is 4. What is 4 to the 0 power? Let's look again at the pattern going down the column, okay, from power and power. So we're going to take this and divide by 4, because 64 divided by 4 gives me 16. 16 divided by 4 gives me 4. And then 4 divided by 4 gives me 1. We got 1 again. So why are we getting 1? Let's talk about why we're getting 1. The directions on the page says what happens when you raise a base to the power of 0. So here we're seeing that as we move down a power, what are we doing? If I move down the power, 3, 2, 1, I am dividing by 2. What is this 2? The 2 represents the what? The base. So as I move down the power, I'm dividing by the base. And what will eventually happen? I'm going to take that base and I'm going to divide it by itself, and that ends up giving me 1. So let's look at the other column. So again, 3 cubed is 27, but as I move down the power, I'm dividing by the base, and eventually I'm going to take that base and divide it by itself. Again, in the next column, I'm doing the same thing. As I move down the power, I'm doing what? Dividing by the base. So as we move down the power, I am dividing by the base of 4, and eventually I'm going to take that base and divide it by the base, and that gives me 1 each time. So we can conclude from this that any number x raised to the power of 0 gives me 1. And why is it giving me 1? Because as I move down the power, I'm going to divide by the base. Okay? So that's it for our exponent lesson with any base raised to the power of 0. We now know it's 1 because as we move down the power, we divide by the base, and it's not 0. 8th graders, I know that this now makes sense to you, and it doesn't matter where you're at. If you're in Charlotte or if you're anywhere around the world, many students believe that it's 0, but as we've proven, it's 1. One of the things I love about Math Extra is that we get to interact with students and help them with their math. It's even better when it's a live conversation. So we're going to go to the phones and see who's on the line. Hello, caller.
I'm here.
Okay, what's your name?
My name is Isaac.
All right, and what school are you from?
I'm from Piedmont Open Middle School.
Oh, yeah, Piedmont. You already know. So, Isaac, what's your question?
Why is 2 to the 0 power 1, but negative 2 to the 0 power negative 1? I thought you said any number raised to the 0 power is 1.
Wow, Isaac, it doesn't matter where you're at, if you're in Charlotte or if you're anywhere in the world, this question for 8th graders always is a good one. So let me see if I'm saying your question correctly. So you're asking, why is 2 to the 0 power 1 and negative 2 to the 0 power negative 1? Is that correct?
Yes.
Okay. So I'm going to rewrite this making equivalent statements because we just said that any base to the power of 0 is 1. That is very true. So 2 to the 0 power can be written as 1 times 2 to the 0 power. Isaac, 1 times any number is what?
The number itself.
The number itself, okay? So we have 1 times 2 to the 0 power, which is going to give us 2 to the 0 power. So 2 to the 0 power, we just learned, is 1. And so I can rewrite this as 1 times 1, which gives me what, Isaac?
1.
1. Okay? And so where students get tripped up on is that they don't know which actual process to do first. So PEMDAS, or the order of operations, reminds us that, Isaac, if I have multiplication and exponents in a problem, which operation should I do first?
The exponent.
The exponent. So that's why we do the 2 to the 0 power first and then multiply it by 1. And we know that 1 times 1 is what, Isaac?
1.
A 1. You're correct. So let's look at the next problem. So negative 2 to the 0 power can be written as negative 1 times 2 to the 0 power. Okay, and so Isaac, what is negative 1 times 2?
Negative 2.
Negative 2. So negative 1 times 2 to the 0 power is going to give you negative 2 to the 0 power. Okay, so negative 2 to the 0 power. Now, we just said, Isaac, that in order of operations, if I have a multiplication and an exponent problem in the same, well, operation in the same problem, which one should I do first?
The exponent.
The exponent. So let's do the exponents first. So 2 to the 0 power is 1, and then we have negative 1 times negative 1. Isaac, what is negative 1 times what is negative 1 times 1?
Negative 1.
Negative 1, okay? So that gives us negative 1, okay? So Isaac, 2 to the 0 power, when we're looking at this, we said that any base raised to the power of 0 is 1. So what I'm going to stress to you is that negative 2 to the 0 power, that this base, let's look at the problem again, that the base is actually 2 to the 0 power, which can be very confusing to students because they see this negative sign here. But that negative sign is saying take the opposite, okay? Take the opposite of 2 to the 0 power. 2 to the 0 power, Isaac, is 1. What's the opposite of 1, Isaac?
Negative 1.
Negative 1. So it's important to know that when that negative sign is out there by itself without any parentheses, that it is not with the base. And that's really confusing for students because many times we say a number is negative 2. That negative is a sign with the number. But here we have to understand that the base is 2 to the 0 power. All right, Isaac, did that help you?
Yes, it did.
Okay, good, Isaac. And more than likely, it's helped a lot of 8th graders as well. It's good talking to you, Isaac.
Good talking to you, too.
Have a good one. Now it's time for my 8th graders to shine. It's the Math Extra credit. 8th graders, if you can solve this problem, send me your answer. Negative 2 squared times negative 1 to the 0 power times 3 to the 0 power times negative 5 to the 0 power. Listen, I know you can do this problem. You've been taught what a negative exponent raised to the 0 power really is. That's it for this episode of Math Extra, the show that puts you on the right path in math. Listen, I hope you learned something today. I know things aren't the way they used to be, but you can still challenge yourself and you can still learn. And that's why we're here. So be smart, be safe, and we'll see you next time on Math Extra.